All right, so we're going to talk about ellipses. So ellipses are very, very similar to circles. The difference is we're going to talk about ellipses. They're kind of elongated along an axis. So we're only going to elongate along the x-axis or the y-axis or horizontally or vertically. Okay, so an ellipse is a set of all points in a plane such that the sum of the distances from that point to two fixed points called the foci is constant. So here in our diagram, we have focus 1 and focus 2. Those are 2 points kind of quote unquote inside the ellipse. If I take a point on the ellipse, so the distance from foci 1 to P, that's distance 1, here's distance 2. So I have point 1, I have point 2. The sum of these distances is always going to be constant. It's always going to be the same. Okay, so this is what an ellipse is. So we have a lot of different pieces on this. So we have our major axis, which is going to be the longest length through the foci. That's our major axis. So this right here is going to be our major axis. Oops. And our minor axis is going to be the smaller. Okay, so this is minor. Okay, where those two crosses are centered, kind of like our circle, it has a center point. We base everything off that center point. We based our foci off of it. We based our vertices. We based our co-vertices. So our vertices are the sides of the ellipse along the major axis. So these 2 points here would be our vertices. Our co-vertices are along the minor axis. So in this example, it's the ones up and down. So here we have our equations, our basic equations for it. So this puts us at a center that is not necessarily the origin. So we can shift this around based on h and k. So we can move it up and down and left and right. So if I have a horizontal major axis, what's going to happen is a squared is going to be bigger than b squared, or a is bigger than b. If b is bigger than a, then I have a vertical ellipse. Okay, so my equation here is x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. That's the same no matter what. Okay, so it's going to be the same equation. I'm just looking at the comparison between a and b to determine which is the major axis. Okay, so here my major axis is going to be horizontal on my first one, vertical on my second one. My center for both is hk, but now my vertices change. Okay, so to find my vertices, what I'm going to do is I'm going to take the square root of the larger of these. Okay, so I'm going to just talk about the horizontal for a second. So a squared is going to be bigger than b squared, so I'm going to take the square root of a, I'm going to add that and subtract that to h. Okay, so that's going to be my vertices. My co-vertices is I take the smaller and subtract it from its corresponding coordinate. Okay, so here b squared would be smaller, so I take the square root of b squared, I get b, I add and subtract that to k, there's my co-vertices. Now for my foci is going to be this letter C. Okay, so I'm going to add and subtract that from my center coordinate along the major axis, and we'll kind of get to that. Now C is the difference of a squared and b squared. So it's going to be the positive side of that. So if b squared is bigger, go b squared minus a squared. Okay, so we want that to be positive, and we want to square root that. So the square root of a squared minus b squared. I've seen some texts where they just put an absolute value around a squared minus b squared, so it's always positive, so you don't really have to worry about it. It's always the same. So just subtract and get the positive. Okay, so the equations are going to be very, very similar. It's just going to be different where you add them based on whether it's horizontal or vertical. Okay. So here are example 1. We're trying to get back to our equation. So this equation here. The other thing that I want you kind of to look at is ellipses, when we're in our standard form here, it's x minus h quantity squared over a squared plus y minus k squared over b squared equals 1. So we're always wanting to get this to equal 1. Okay? So one of the ways that you can tell if it's a circle or an ellipse is look at the coefficients. If the coefficients out here in a basic equation, if they're the same, it's a circle. If they're different, they're an ellipse. So here are example 1. They give us a vertex and a co-vertex. And they want us to find the equation. Okay? So if my vertex is negative 6, 0, I already know that I'm changing my x coordinate here. Because notice here I have a 0 and a 0. So my center is actually 0, 0. Okay? So the nice thing is that's going to give me x squared over something plus y squared over something equals 1. Now to find these numbers below here, what's going to happen is I'm just going to take the value here, negative 6. I go from my co-vertex, so 0 to negative 6. That gives me negative 6. I square it. That gives me 36. Okay? I'm going to do the same thing, 0 to negative 3. Okay, the difference there is 3. I'm going to square it. That gives me 9. So my equation is going to be x squared over 36 plus y squared over 9 equals 1. Now in example 2, they want us to find a bunch of different things. They want us to graph this. They want us to find the foci. So we're actually just going to find everything. Okay, so we're going to find the center. We're going to find both sets of vertices. We're going to find the foci. And I'm going to show you how to graph it. Okay. So the very first thing we have to do is we have to get this equal to 1. So I'm going to divide everything by 225. Just so I can get this in a nice form here. So this gives me x squared over 9 plus y squared over 25 equals 1. Now I can see which one's going to be have the major axis. I've already noticed that my y squared has a large number on it, so that's my major axis. So I have a vertical major axis. All right. So I'm going to find my center. Well, what makes that 0? 0, 0. There's my center. So for my vertices, okay, I'm going to have 2 vertices. What I'm going to do is I notice that the y has a larger value beneath it. So I'm going to take the square root of that and add it and subtract it to my y coordinate. So my x coordinates are still going to be the same, 0, 0. Okay, so I take the square root of 25. That gives me 5. So I'm going to add that. That gives me 0, 5 and subtract it, 0, negative 5. Okay, now I'm going to find my co-vertices. And on my co-vertices, my minor axis is the one that's changing, my minus. So my major for my center is not going to change, so they both have zeros there. And now I'm going to take the square root of the value of the smaller. So I'm going to take the square root of 9, that gives me 3. So I get positive 3, I get negative 3. Okay? So now I'm going to find my foci. So the first thing I need to do is find C. So C is the square root of the difference. So I'm going to take this. I get 25 minus 9. That gives me 16. Square root of 16 is 4. So this one's nice. If it wasn't nice, if it was just a square root, I would probably leave it as a square root, and I'm going to kind of show you that. So since my major axis is a vertical, what I'm going to do is I'm only going to change my y coordinate. So I'm going to go 0, 0 plus or minus 4. If that was a square root, I'd just leave it like that. I would go my y coordinate plus or minus that square root. This case, it's not. So I have 0, 4 and 0, negative 4. Okay? So let's look at, oh, and I need to graph this. So I want to graph this here. I don't have a lot of room, so I'm going to erase this C here. 1, 2, 3, 4, 5. And so the first thing I'm going to do is plot my center. Okay, so my center is 0, 0. Now, I already know my major axis, so what I'm going to do is I'm going to take the square root of 25. That gives me 5. I'm going to go up 5, 1, 2, 3, 4, 5, down 5, 1, 2, 3, 4, 5. That's my major axis. I'm going to square root the 9. That's going to give me my minor axis. So I'm going to square root 9. I get 3, 1, 2, 3, 1, 2, 3. Connect those. There's my ellipse. Okay? So you're going to find your center. You're going to use your major axis, your minor axis to be able to graph that. Right? So let's look at maybe one more example here. Let's see here. Let's say I have -5, 0, and 5, 0 is my foci, and my vertices are -8, 0, and 8, 0. Can I get back to my equation? So this part, I don't have my v, so I have to find my v. So the nice thing is we can kind of figure out our vertices here, or I'm sorry, our center, pretty easy. Because if you have your two foci, your center has to be in the middle of them. Okay, so what's halfway between -5 and +5? Well, that's 0. What's halfway between 0 and 0? Well, that's also 0. Okay, so there's my center. All right, so I know that this is going to be x squared plus y squared equals 1. I'm just looking for the numbers below that. Well, I already have a, because what I can do is I can take this, the distance from my center out to my vertice, and square it. So the distance from 0 out to -8 or 0 to 8 is 8. I square it, that gives me 64. Okay? So now I have a little bit of work because I have to find what b is. Well, remember, c is equal to the square root of a squared minus b squared. Well, I already have c, I already have a, so 5 equals 8 squared minus b squared. A squared is 64, so I could have just substituted that in. Okay, I'm going to square both sides here to get rid of that square root, so that gives me 25 equals 64 minus b squared. I'm solving for b squared, so I'm going to subtract off 64 minus 64, and what does that give me? -41 equals -b squared, or b squared equals 41. I really only need that. I really only need the 41. I don't need to square root it and actually find what b is. Let's see. And of course I did that wrong. This is 39, sorry. Right? 64 minus 25 is 39. So 39 becomes my b squared. Okay? So that's ellipses. Just remember that to get it equal to 1, find your center. From your center, you can find your vertices, covertices, and foci.